Hello and welcome to the recitation, recitation 4. Guess I'll be correcting that. Video. Just put that there for later. Anyway, so this is just a rehash of what hopefully you watched the video yesterday. And we're just going to do some problems that hopefully will help solidify how these things work. First of all, we're going to do arc length. Arc length, we have the formula here. And so the first deal with this one is we're going to need to figure out what t is, or rather the a and the b, the limits. And so the easiest thing to use probably is this right there. And so 3t over pi is going to equal 0 and for the first point, and that gives you t equals 0. So that is t equals 0, and then you have 3t over pi equal to 6. And that gives me t equals 2 pi, and that corresponds with that particular point there. So the way I'm going to write, though, let's get the derivatives first. R prime of t is the negative sign, and then 3 over pi, and then the cosine. Okay, so now we just have to do the integral from 0 to 2 pi of the square root. Notice I'm just going to use, this is the easiest one to remember. I mean, this is useful for other reasons, but I'm going to use that up there, the derivative. So I'm taking this sine of t and squaring it. And of course, the negative goes away. And then this is 9 over pi squared. And this will be cosine of t squared. Oh, plus. I'm adding these together. There we go. So it matches this right there. Now, in almost all cases, if you have to compute arc length or reparameterize or whatever it is, we're going to make sure that these things work out nicely, especially on an exam. I don't know, I can't speak for Adfinity. But this one is one of those. Notice that these two together give you 1. So this will be the integral from 0 to 2 pi of 1 plus 9 over pi squared. We could clean this up a little bit more, but why bother? So this is just a constant. So that is a constant. And so that will equal that constant, 1 plus 9 over pi squared, evaluated from t equals 0, times t to t equals 2 pi. So when you integrate a constant with respect to t, you just get that constant times t. And so this is just 2 pi times the square root of this nasty thing. I suppose I could clean this up. This is fine. I mean, okay, I'll clean it up, though. 2 pi. This will be pi squared plus 9 over pi squared, which is 2 times radical pi squared plus 9. There. Looks a little bit nicer this way. So we'll go with it. All right, let's do the same thing using this this function. It looks really similar. And I'll even tell you a secret is that, or not really a secret, but that these are the same curve. So those are the same curve. It's just a different parametrization of that curve. So the long and the short of it is that we should expect to have the same answer here. But so this is the same curve as number 1, but a different parametrization. Okay, so let's do the same deal here. I'm going to try to figure out what the values for t are for these. So this one is t equals 0. And I'm just using the 3t there. So 3t is equal to 0, which means that t equals 0. And then this one over here, I have 3t equals 6, which means that t equals 2. So let's put these together. From t equals 0 to t equals 2. Oh, I need my derivatives. I can do them on the fly. How about? So this will be the derivative of cosine of pi t, which is going to be negative pi times the sine, chain rule, and then 3 squared, and then, let's see, this will be pi times cosine. Let me clean this up a bit. We're going to have the same situation that we did before. So 0 to 2, this will be pi squared times sine squared pi t plus cosine squared of pi t, and then plus 9. And you can see that that sine squared plus this cosine squared equals 1. That's nice. So all of this is going to equal this. Oh, that looks familiar, doesn't it? So anyway, that's a constant, whatever it is. I don't know what number that is, but it's constant. And so this will be pi squared plus 9 times t. That's the way you do the integral. Here, I'll just write this down. And t goes from 0 to t equals 2. Now we can just plug it in and be done. So this will be 2 times radical, what do I need that there? Pi squared plus 9. Look at this, it's the same. It's the same, yay. Okay, so same as before. Yeah, so it's just the same curve, just a different parametrization. So anyway, let's move on. Let's reparameterize that curve. So I've written this with u here. I read the book after making the video for yesterday's class, and realized that it would be a lot easier to do this if we just had a u there instead of a t. It's the same function. You know how it is with variables. You can name them whatever you want. And so the first step for finding this formula is we're going to find r prime of u, I guess is what we're going to call it. So we already know what this is. It's up here above. So this will be negative pi times the sine. And then 3, and then pi times the cosine of pi times u. Okay, number 2 is we're going to do the magnitude of this thing. Because this is all in service of computing the arc length. Find a formula for, another typo. S of t. Oh, yeah. Okay, I see. Sorry. I guess I was thinking I was doing this problem, which is the second part of this, but we'll get there. So this isn't a reparameterization. This is just finding a formula for S of t. It's kind of like a formula for the arc length, where this t is a variable instead of being 2, the upper thing of this. So anyway, now I need the magnitude. Oh, you know what? I can just do this. Yeah, let's just do this. S of t. Yeah. S of t is going to be the arc length from 0 to t. So notice that those are my limits of the square root of negative pi. We've already done this. So this is a bit redundant. 3 squared pi times cosine. And this is with respect to u. So the main difference between what we did up here is that this stuff is in with respect to t. Down here we have with respect to u, but it's the same exact thing. So let's not belabor this. Whoops. So this is arc length is s of t. And I'll just cut to the chase here. And you know how this is going to shake out. U goes from 0 to t. So this all will be this square root times t. Done. So that's the arc length, literally the arc length from 0 to t on this curve. Now I'm going to use that formula to reparameterize this by arc length. So here's how this works, is we have s is equal to the square root of pi squared plus 9 times t. Just solve this for t. That means that t is equal to s over this radical. And then I'm going to shove that in up here, and I get r of s is going to be the cosine of pi s over the square root, and then 3 times s, let's write it like this, and then the last one, which is sine of pi times s over the square root. And that's it. So all that does is that what this does is it will make it so that the distance between s equals a and s equals b on this curve will be b minus a. So just, this is going to be convenient for future stuff that we do. Onward. Let's do a unit tangent vector problem. This is easy enough. So you know the deal here, that the unit tangent vector is the derivative divided by its magnitude. So in this case, we get our derivative. Oh, this looks familiar. 3, and then pi times cosine of pi t. There we go. Now let's find the magnitude of this thing. Oh, first of all, since I'm done doing derivatives, I can actually plug in a now, because notice this formula, you have a is on the top and bottom. You don't need the t anymore. So once you've done your derivative, your t has served its purpose. Oh, a is 1/2. Okay, so this will be negative pi times the sine of pi over 2, 3, and then pi times the cosine of pi over 2. Okay, so this is, let's see, the sine of pi over 2 is 1, cosine is 0. There it is. And now the magnitude of this, whoops. So pi squared plus 9 plus 0. That looks familiar. Well, we're still on that same function, so if you're hankering for another one, take a look at 6. Okay, but anyway, getting back to this, now we're just going to do the unit tangent vector at 1/2 is going to be this vector, all divided by this pi squared plus 9. All done. All right, let's do the same thing with this. Hopefully more interesting things. We're kind of getting sick of the sines and cosines. I am, at least. Do your derivatives. Now we're going to plug in 2. Now we're going to compute the magnitude. Okay. Oh, look at that. 289. Square root of 289, 17. And so then that's the unit tangent vector at 2 is going to be this over 17. And we're done. Okay, one more page. We can do this. Tangent lines. Oh man, the same problem. Well, fortunately, we've done all the work pretty much. So with the tangent line, let me remind you, we have, we're just going to do r of a plus r prime of a times t. So it's very similar to the tangent line formula for Calc 1. So we need to do r prime again. Oh, here, let's do r of, okay, this is t equals 2, I think we worked out earlier. So r of 2 is going to be cosine of 2 pi. That's 6. And, oh, duh. It's right there. Okay, that's all right. I'm doing it now. I'm dumb. Okay, so this is going to be 1, 6, 0. Okay, r prime of t. Done this so many times. Sine of pi t. 3 negative, or no, positive pi. Okay, things are getting messy here. Whoops. So r prime of 2, I feel like we've done this one as well. That's going to be 0, 3, and pi. Oy. Okay, now let's just put this all together. So we'll call it S of t. I don't know, that's arc length. Maybe I just need a different function. Let's call it f of t. Is going to be, better yet, let's just, here we go. We got this point, we've got this direction. Let's just put it together like this. Whoops, go away. X is equal to 1 plus 0t. Y is equal to 6 plus 3t. And z is 0 plus pi t. So notice that I'm just putting those things together. And you can write this like this. 1, 6 plus 3t, and pi t. So however you want to write it, I'm just going to box this up. So I could write it as a vector function, but I've run out of letters. So we'll just do it that way. Okay, last one. Oh, look, we did this one as well, r prime. Okay, so that, I suppose I need to work out, I think is t equals 1. You can tell because of this. So r prime, here again, 2 over t, 3t squared, and 12. R prime of 1 is 2, 3, and 12. And so this will be x is equal to 2t, y is equal to 1 plus 3t, and z is equal to 12 plus 12t. There you go. All right. Well, thanks for watching, and don't forget to smash that like button.